Okay, this is 3.6b of algebra. So we're continuing with compound inequalities. Now we're going to look at solving a compound inequality that has an OR. So when we have an OR, they're just two separate inequalities. So, whoops, here's one, and here's the other one. And I just solve them individually and put my answers together at the end. Because my answer then is t is less than -3 or t is greater than 1. So, a lot easier. Basically, you're doing exactly what we've done before. You just have to do it twice. So, let's try our got it problem down here. -2y plus 7 is less than 1. So, I need to get y alone, so I'm going to subtract 7. That cancels off, so I have -2y is less than -6. And then I divide by -2. What do I do when I divide by a negative number? Flip that sign. So, y is greater than 3. And now I'm going to solve my other inequality. 4y plus 3 is less than or equal to -5. So I'm trying to get y alone, so I'm going to subtract 3. Cancel off over here. I'm just left with 4y is less than or equal to -8. Divide by 4, divide by 4. And I get y is less than or equal to -2. And then I'm just going to stick those both on the same graph. We'll graph it up here. So I need to have -2. That's supposed to be a 2. And on the other side of the graph, I'll need, well, I might as well just keep going with it. 1, 2, 3, 4. Okay, so first I'm going to work with the first one that we did. So y is greater than 3. So that's going to be an open circle at 3. And then I'm going to plug in a number. I'm going to plug in 4. 4 is greater than 3. That's true. Okay, at -2, I need to have a closed circle. If I plug in -3, I get -3 is less than or equal to -2. I would rather owe someone $2 than $3. So this is true. So I go towards the -3. You can plug in, but also, here's a little trick for you. Whenever we're working with the OR compound inequalities, so when we were given two separate inequalities, they're always going to be going like that. Right? If they were both going towards each other or something like that, then we would have an and one. So whenever it's an or, you can put your circles on and just draw them out to the sides. Alrighty. Okay, interval notation. So this is just a different way that we can write our inequalities. So let's look at this picture here. When we are using a closed circle. So here's a closed circle. I'm going to use a square bracket. One of these guys, like that. When it is an open circle, I'm going to use a parenthesis, or parenthesis like that. Okay? When I'm talking about to infinity and beyond, so see how this keeps going? It's going to go on to infinity, okay? Infinity is not a concrete number. It's not one number. I can't count and then be like, and then I get infinity. Like, and then infinity 1, infinity 2. No, that doesn't work. So, you can kind of imagine as if there's an open circle on infinity. I can't ever really get to infinity. I can't ever include it. So, we use a parenthesis whenever we have infinity. So you'll see here we've got infinity, so we've got a parenthesis. Here we've got infinity, so we've got a parenthesis. This happens to be negative infinity, but we still use parentheses. Down here I've got infinity, so I use a parenthesis. Infinity, so I use a parenthesis. So, if it's one of our regular, or one of the older kinds of inequalities we've done, just a plain one, I've got a square bracket on my 2, because there's a closed circle at 2, and then I put a comma between them, and it goes on to infinity. So I have square bracket, 2, comma, infinity with a parenthesis. Same idea here for this guy. My 2 this time is on the right side because it's the biggest number. And then a comma, and that goes all the way to negative infinity. I use parentheses for both of those ones because I've got an open circle and I go to infinity. We can also use interval notation when we have a compound inequality. So I've got parenthesis 1, comma, 5 with a square bracket because that's a closed circle. And I can use it for my OR statements, right? This was an AND compound inequality. If I'm using an OR one, I'm going to have the actual word OR in there. So this guy over here, the smallest it's going to be is negative infinity, and I use a parenthesis for that. And then it goes to negative 3, and it's an open circle. So I use a parenthesis. Or, and then I look at this guy. So I've got a square bracket because it's closed, a closed circle. So I got 4, comma, and that goes on to infinity, and I use a parenthesis. Ooh. Okay, let's give it a shot. Okay, let's look at our got it problem here. What is the graph of parenthesis negative 2, comma 7, square bracket? So I can first of all say negative 2 and 7, right? I need those. Since I have a parenthesis with a negative 2, that means I have an open circle. Since I have a square bracket with a 7, that means I have a closed circle. And then I connect them. If I wanted to write that as an inequality, I'm going to have negative 2, some variable. I'll choose x. And then 7. Negative 2 is my smallest number, and it's not included. So I'm eating the x, and I don't have the line below. 7 is my biggest number, and it is included, so I have it eating the 7 with a line underneath it. Okay, I'm going to erase this so that I have some room down there for our next problem, because I wrote big. Okay, what is the graph of y is greater than 7? So I know that I need to have 7 on there. I'm going to plug in, oh, that's a bad 6. I'm going to plug in 6, and I'd get 6 is greater than 7. Kind of looks like a 7. This is a struggle. 6 is greater than 7. That is false. So I'm not going towards a 6. So I've got an open circle at 7, and I'm going to go towards 8. And if I wrote that in interval notation, this is an open circle, so I have a parenthesis with the 7. And then the biggest number I can go to is infinity. So infinity, and we always use parentheses with infinity. And there's your homework.